My earth science faithful. All right, here we go. Video. I think this is like 6. Now we're going to get into air masses and what's what with air masses. So definition of air mass. You don't have any. You can write this next to the map with the circles. Okay. What is the definition? It's a large body of air with similar characteristics. So I'm looking in the notes. Right. You can write that over here. We're going to come back to the picture in a minute. Okay. Air masses are classified based on their temperature and the amount of moisture. Is it warm or cold? Is it humid or arid? Okay. That's the first piece under the picture. Then the next piece under the picture. They get their characteristics based on where they form. Okay. Let's get into the symbols. And in your packet, it should be a little c and a little m, I think. So let's just make sure it's a little c and a little m. Should be. So little c means continental, which means dry. Over the continent, there's not that ability to grab the moisture out into the air where it would be in maritime. Maritime means kind of ocean. So that means it's going to be moist. It's going to have high humidity because the air came from over the ocean. Okay. Capital T stands for tropical, which in this case means warm. P means polar, which is cold. And then A stands for Arctic, which is very, very cold. Okay. Just to make sure we get all that taken care of. So we know that maritime with a T is going to be moist and warm. And continental is dry. And P is polar, so dry and cold. Okay. That's how we use these. Okay. Now we can go back up to the picture. From each of these places where it comes from is these symbols. So little c, capital A, continental Arctic air mass, dry and Arctic super, super cold. Maritime polar. So maritime is wet, polar is cold, right? CP, MP. See what's happening here? The CP happens over the continent, maritime happens over the ocean. Okay. I got MT, I got CT, and I got MT. These are tropical air masses. These are warmer. Notice these are coming from closer to the equator. Okay. Almost done with this video. Now we got to figure out what fronts are. Oh, here's a cool picture of what we just did. Nothing here for you to write, just to understand how this is all playing out. Oh, high or low pressure. From our previous learning, maritime, wet, and warm is low, where cold and dry is high. Some pictures of what it looks like. This is like what you might see fronts on the news, right? You see the old school weather. And here's a cool, more satellite image of what's happening with weather. Let's get into these fronts. The fronts are a boundary interface between air masses. You need to know that the symbol points in the direction of the travel. So that didn't come up, but you need to write that. Ready? The symbols point in the direction of the travel is what you need to write underneath this. A boundary interface is an interface between air masses. All right, cold fronts. There's a picture of a cold front passing through, driving the warm air up. Here's a picture of what it looks like in reality. And then warm fronts rise up over the cold air. Cool. Okay, so we need to go back and put in some notes that didn't come flying up. Okay, so back to cold front. Doesn't say to write anything in the PowerPoint. So precipitation is at the leading edge, the very front of the cold front. And you see its symbol is triangles. Okay, so you want to kind of draw this a little bit here, something similar to this, where the front is moving with a little C and a P. It's a cold front, continental, dry, polar, cold, and the less dense air is going to rise up. On a warm front, you need to write that the precipitation is at the trailing edge, not at the front edge. You can draw a little picture kind of like this. The less dense air rises up. It is the MT going up over the CP. Okay. Now we have stationary front. So notice this has both symbols, triangle and rounded. Cold air mass and warm air mass meet in stalls for many days. There's usually precipitation between them. Okay. Good, good. Notice they're in different sides of the front. Because when they're on the same side, we call it an occluded front. So there's the difference. This cold air mass catches up to the warm air mass. Right? The cold air mass, more dense, forces the warm air up, causing condensation and precipitation. This is what happens when they meet. Okay? An occluded front. Okay, so that's all the different fronts that we need. And then, so here's the rule, A, B, C, D, E, just some examples. Ready? The triangles and bumps always point in the direction the front is moving. Now, that's something I asked you to write on the other page. You might want to write it again on this page just to make sure you have it somewhere. But that is the rule. Okay? Now I'm just going to run through these quick notes and we'll do stationary models in the next video. So this guy, triangles is cold front, and it's going from the north heading south. Moving south, cold front. This is on the same side of the front, so this is an occluded front moving north. This is a stationary front with the cold side on the bottom and the cold side on the top, warm side on the bottom. Nope, cold air on the south side, I lied. Warm front heading north. Stationary front now with the cold side, with the warm air on the south side. Seems backwards to me. But not all things in science make sense to me. All right, good. All right, that should do it for this video, and I will see you guys in a little bit.